Hi everyone, Miss Monday here. I know I explained this question in class, but I just wanted to re-explain it just to make sure everybody got it. So we have to find the turning points. Those are maxes and mins. That's when the first derivative equals to 0. And points of inflection, those can be stationary, which will also come up when the first derivative is equal to 0, or non-stationary, when the second derivative is equal to 0. Okay? So what I'm going to do first is I'm going to take the first derivative. We need to use product rule. I'm going to try to color code this. And then when we take the derivative of the second, we're going to use chain rule. So we'll do, hold on. Okay, how to get my colors going. All right, we'll do derivative of the first times the second plus derivative of the second. Now we're doing chain rule. So we're going to do derivative of the outside, leaving the inside the same, times the derivative of the inside, then back to times the first function. Okay? So again, this is derivative of the first times the second plus derivative of the second times the first. Okay? So if we simplify this, we get x minus 3 cubed plus 3 times x plus 1 times x minus 3 squared. Now we have two terms because terms are separated by a plus or a minus sign. And in both of those terms, we have a greatest common factor. And the greatest common factor will be x minus 3. We have 3 of them here and we have 2 of them here. So the most that we can divide out are 2 of them. So what I'm going to do is I'm going to factor out x minus 3 squared. And then here I'm going to write what I have left. So in this first term, when I take out 2 of them, I'm left with 1 of them. So x minus 3. And when I take out all of these, I'm left with plus 3 times x plus 1. We're factoring out the greatest common factor, okay? Now, what I'm going to do next is I'm going to distribute and combine like terms inside of the red parentheses. So I have x minus 3 squared times x minus 3 plus 3x plus 3. And now I'll combine like terms. So I have 4x, yeah, that's it. So basically I have 4x times x minus 3 squared. So I set this equal to 0. So 4x would equal 0, which means x would equal 0. X minus 3 squared equals 0. Take the square root and add 3 over. Okay, so let's make our sign diagram. For that, we're going to have 0 and 3. And we're plugging that into our sign diagram. We always plug into our derivative. So I'm going to plug in, for example, -1, +1, 4. Okay, 4 is always positive. This is always positive because it's squared. So it's really just like what we plug in. So if I plug in a -1, I have a positive times a negative times a positive is a negative. If I plug in 1, I have a positive times a positive times a positive is a positive. And if I plug in 4, positive times a positive times a positive is a positive. Okay? So this is decreasing to increasing. We have a 0. This is increasing to increasing. We have a stationary point of inflection. Okay? What should we do now? Let's just keep going with the second derivative. Okay, we'll finalize the answer in a second. All right, so now we're going to find the second derivative. So the second derivative, remember that the first derivative is 4x times x minus 3 squared. Again, I'm going to use product and chain. So when I take this second derivative, I'm going to do derivative of the first is 4 times the second as it is, plus the derivative of the second requires chain rule. Derivative of the outside leaving the inside the same, times the derivative of the inside times 4x, the first function. Okay, so this is 4 times x minus 3 squared plus 8x times x minus 3. I have two terms. I can factor out a 4, and I can factor out an x minus 3. Okay, so I'm going to factor out my 4 and x minus 3, and what am I left with? I factored out this, I factored out this, I'm left with x minus 3. Out of here I factor out a 4, so I'm left with 2x, and I factored out that. Now let's combine like terms. So we have 4 times x minus 3 times 3x minus 3. And then look, here I also have a greatest common factor of a 3. So I'm going to factor out the 3. You can, you don't have to. Okay, so I have 4 times x minus 3. I'm going to factor out the 3, and I'm left with x minus 1. These multiply together, so finally I have 12 times x minus 3 times x minus 1. So x equals 3 and x equals 1. We already knew that the 3 was going to come up because it was a stationary point of inflection. Stationary points of inflection show up both in the first and the second derivative. So I'm making my sign diagram for the second derivative. I'm going to plug in 0, 2, and 4. So when I plug in 0, I'm going to have a positive times a negative, which makes a positive. When I plug in 2, I'm going to have a positive times a positive, which is a negative. And when I plug in 4, I'm going to have a positive times a positive, which is a positive. Okay? So this one, since it showed up in the first derivative and the second derivative, it's a stationary point of inflection. And since this one only showed up in the second derivative, it's a non-stationary point of inflection. All right, so our answer now. Okay, remember that our original equation was x plus 1 times x minus 3 cubed. So what I have the point when x equals 0, when x equals 1, and when x equals 3. So let's find the y value. F of 0, I would get 1 times negative 3 cubed. That's 1 times negative 27. So I have the point 0, negative 27. When I plug in 1, I have 2 times negative 2 cubed. So that's 2 times negative 8. So that's negative 16. And then when I plug in 3, I'm going to have 4 times 0 cubed, so that's 0. Oops, 3 comma 0. So 0 comma negative 27, that was a local min. 1 negative 16, that was a non-stationary point of inflection. And the points 3 comma 0, that was a stationary point of inflection. 9-minute problem. I hope that helped. Have a wonderful day.